In this video, we'll look at the concepts of impulse and momentum. So by the end of it, you should be able to define the terms momentum and impulse and be able to solve problems using the equations for momentum and impulse, and also to be able to derive the relationship between net force and momentum in terms of Newton's second law. So let's start with defining momentum. So the momentum of an object is the product of its mass and its velocity. And mathematically, we write it as P equals m times v, where P is the momentum and the units are kilograms times meters per second. So obviously that comes from kilograms times meters per second. M is for the mass of the object and V is for its velocity. So remember that since velocity is a vector, then momentum is also a vector. Now the concepts of momentum and inertia are related. An object with a large mass or is moving very fast, or both, will be difficult to stop or change direction, and therefore more likely to continue its original motion than would a smaller, slower mass. So that seems quite intuitive. Okay, so let's work through a couple of sample problems using our strategy for problem solving. So number one, find the momentum of a truck that has a mass of 6.010 to the 4 kilograms travelling at 12 metres per second north. Okay, so we're after the momentum and we're given the mass and the velocity. Okay, so the first thing we need to do is write the formula that we'll be using, and then we substitute. So now we solve. Okay, so now problem 2, we've got a mass of 1.4 tonne. A momentum is given this time of 1.310 to the 4 kilograms times meters per second east. Okay, so this time we need to determine its velocity. So we've got 1.4 tonne, so which is equivalent to 1400 kilograms. Okay, so same strategy, we write the equation and we substitute and solve. Okay, so I've provided you with a problem set and the questions out of the textbook. Here's the reference to it, and I've also supplied the answers so that you can check, but I will post the workings into Google Classroom. So now we're going to look at using Newton's second law to derive the relationship between the net force and momentum. The net force can also be written, and that's how it is in the syllabus. So this is Newton's second law written mathematically. Okay, so since we know what acceleration is given as the change in velocity over time, or the change in time. So if we substitute that into this equation, we get, and we can also write this. Now recall that momentum is given by mass times velocity. So this is the final velocity and we've got the initial velocity. So that means we've got the final momentum and the initial momentum And because of that, we can write it like so, or simply as, where delta P is the change in momentum. Now, another term that we use for change in momentum is impulse, or in symbols. Now, if we substitute this relationship into here and rearrange it, we get another relationship or equation for impulse. So from this, we can define impulse as the product of the net force acting and the time for which it acts. An impulse is also a vector quantity. Okay, so a couple of sample problems. We've got a hammer strikes a nail with a force of 125. Assume contact time between the hammer and the nail is 0.020. Find the magnitude of the impulse applied. So since it's asking for magnitude, you don't have to state the direction. Okay, so we write the formula and substitute and solve. Okay, so the unit is Newton seconds. So problem 2, we've got a car collides with a wall. The car and the wall make contact for 2 times 10 to the minus 1. If the impulse of the car that the car experiences is 1.2 10 to the 4 Newton seconds east, determine the average net force acting on the car while it is in contact. Okay, so we write the formula, substitute, rearrange and solve. Okay, and so the direction is the same as the direction of impulse.